Hello students, welcome to another session of theory of equations. So in the last class we have seen the behavior of polynomial function using the leading coefficient. In today's session we are going to see the same behavior of a polynomial function using multiplicity of 0. So what is this multiplicity of 0 is all about? So let us recall what is 0 of a polynomial. So 0 of a polynomial is already we know very well that a value of variable which satisfies the polynomial function. So here sometimes we will get the same 0 occurring or repeating so many number of times. If you take a quadratic polynomial x square minus 2x plus 1 equals to 0, this is a quadratic equation. Or if you take quadratic polynomial x minus 1 whole square, that means x is equals to 1 comma 1 will be the zeros of the polynomial. So same 0 is repeating. Similarly, if you take cubic polynomial or biquadratic polynomial or pentic polynomial, there is or any other nth degree polynomial, so we will get some repetition of the zeros. So this repetition is nothing but the multiplicity of zeros. So we can define the multiplicity of zeros definition as multiplicity of 0. So multiplicity of 0 nothing but number of times a factor has been repeated. Number of times a factor of a polynomial is repeated or occurring. Let us take small example. F of x is equals to x plus 3 into x minus 2. Now the condition for this multiplicity of 0 is the polynomial has to be written in the factor form, and we have to write the factor form in such a way that the factor whichever is repeated we have to express in the form of an exponent. So here in this example x plus 3 and x minus 2, simple. So we can say that the exponent of this factor is 1, exponent of this factor is also 1. Now by seeing we can say that x is equals to minus 3 is the 0 of this polynomial function. Similarly x is equals to 2 will be the 0 of this polynomial. Suppose if I want to talk about the multiplicity, so how many times this x is equals to minus 3 is occurring or repeating, so based on this exponent we can express. So multiplicity is 1. Similarly x is equals to 2 is having, that means x minus 2 is having the power as 1. So here also multiplicity is 1. Let us take one more example. G of x is equals to x minus 3 whole square and x plus 2. Now what can you say about the exponent of the factor here? So we can decide first 0, x is equals to 3 and x is equals to minus 2. Here the power is 2, here the power is 1. Exponent is 1. Now multiplicity of this x is equals to 3 is 2. That means it is occurring twice. Similarly, multiplicity of this one is 1. Multiplicity of this minus 2 is 1. So this is about brief introduction about multiplicity of zeros. Now how this is going to be helpful in deciding the behavior of the polynomial function graph. So we will combine this topic multiplicity of 0 along with x-intercept on the graph. So when you take this one on a graph, how it will represent? So multiplicity is of 0 and x-intercept. Here we have two cases. The first case is when, let us suppose r is the 0 of this any polynomial. If x is equals to r is a 0 of even multiplicity. Even multiplicity. So let us see what will happen to this graph. The conditions are, first one, the graph touches and turn around. The graph touches what? X-axis and turn around. What is meant by that? How it can be seen on the graph? Let us take one example. F of x is equals to x plus 1, x minus 1, x minus 2 whole square. By seeing this one, we can say that, already I said that the polynomial has to be written in the form of factors. I have written in the form of factors. And what will be the 0 here? X is equals to minus 1 will be the 0. X is equals to 1. X is equals to 2 is repeating twice. Multiplicity of 2. So at that particular x value, the graph will touch the x-axis and turn around. So let us see on the graph. This is the coordinate plane I have taken. 1, 2, 3, minus 1, minus 2. Let us take some even count on the y-axis. Now, x is equals to minus 1 will be 1, 0. It will touch the x-axis, whatever the curve I am drawing. And it will touch 1 and it will touch 2 also. At 2, because of this multiplicity 2, how the nature of the graph will look like? So graph touches the x-axis and turn around. So this will be the nature of the graph. So this is the nature of the graph. So it is touching the x-axis and turn around. In other words, we can say that it is bouncing the x-axis. Bounces x-axis at x-intercept. So what is x-intercept here? Whichever the multiplicity we are having, at that particular 0, it is bouncing. Just like we are tapping the ball on the floor, and when it is bouncing, just like that, it is bouncing at 2. So this is the nature of the graph when it is having even multiplicity. Similarly, we have case 2. So now x is equals to r is a 0 of odd multiplicity. So what will happen to the graph? Now graph will cross the x-axis.Hat's the meaning of crossing? What is the difference between touching the x-axis and crossing the x-axis? Touching is nothing but here, it is after cross, this is called crossing. But here, after crossing, we got the multiplicity 2, that means that the 0 to x-intercept, it is bouncing. But whereas here in the case of multiplicity, odd multiplicity, it will cross. So let us see on the graph. So graph crosses x-axis at x-intercept, wherever we have that multiplicity. So let us take one example. So f of x is equals to 3 whole cube 3x 1. So this is the nature function, polynomial. So when you draw the graph, so this will be same 0, 1, 2, 3. So we don't have any negative zeros. So the graph will fall on the completely right side. So x is equals to 3, here x is equals to 2 by 3, here x is equals to 1. So that means somewhere at x is equals to 2 by 3 less than 1, it will touch the x-axis, x is equals to 1 and it is crossing this one and x is equals to 3. So the graph will look like So what happened here? It is crossing the x-axis at particular point. This is called as crossing. So crossing the x-axis. So one more topic here which is very important. You can see the nature of the graph just like hills and valleys, peaks and valleys. So these peaks and valleys are nothing but turning points. This is one turning point, second turning point, third turning point. Just like when you are moving on a road, you will take U-turn. So it is taking U-turn here, turning point. Here also one turning point or turning point. So what is this turning point indicates? So this turning point indicates so that whenever the function is increasing, that means reaches from increasing to decreasing, that means rising to falling. Let us see some points on that one. Turning points. What are these turning points? So these turning points indicate that increasing to decreasing, that means rising to falling, and decreasing to increasing, that means falling to rising. So whenever the function is rising to falling or falling to rising, one more concept will come into place, that is nothing but, so let us finish this topic initial state. So before going to that example, so I said that turning points. So how many turning points will be there in this case? So we have seen that 1, 2, 3. What was the degree of the polynomial? The degree of the polynomial was, this was the polynomial, x plus 1 into x minus 1 into x minus 2 whole square. Here degree of the polynomial was 4. So we got 3 turning points. That means 1 less than the degree of the polynomial. So we can say that number of turning points is equals to degree of polynomial minus 1. Similarly, if you take this example, how many turning points are here? 1, 2, 3, 4. What was the degree of the polynomial? So degree of the polynomial was 5. So we had x minus 1, 3x minus 2 and x minus 3 whole cube. So here 3, here 1, 5. 5 is the degree. So 5 minus 1 for 1, 2, 3, 4. Totally 4 turning points. So I was discussing about, so whenever we have turning point, it is deciding rising to falling or falling to. What it will decide? So it is deciding the local maxima and local minima. Let us take one more graph here. This is a graph. Let us scale. Think that we have a curve like this. So what it will indicate? So at this particular turning point, the curve is reaching the peak position. So this is called as local maxima. At what particular point? At x is equals to minus 1, local maxima. Next, similarly, whenever it is reaching the first position or valley position, turning another turning point. So where it is reaching that minimum position? At x is equals to 1, and here x is equals to minus. So at x is equals to minus 1, local maxima and local minima at x is equals to 1. So this is going to be the low turning points. So how to decide how many turning points are there without drawing the graph? Okay, let us discuss one example. Before going to that, I was telling about the number of turning points can be found using a given polynomial function or equation by taking its derivative. So differentiating the given polynomial. So here we have an example. Analyze the roots of the following equation. So let us consider this equation f of x as a polynomial. I told that I have to take the differentiation, that means derivative of this f of x. So what will be the derivative of this one? F dash x. First derivative of this function. So 3 to the 6 x square and 9 to the 8 x and 12. So constant is 0. Next, equate this derivative equal to 0. So when you equate this derivative equal to 0, so factorize this one. 6 will be common. X square minus 3x plus 2 equals to 0. X square minus 3x plus 2 equals to 0. When you factorize this one, you will get x minus 1 and x minus 2 equals to 0. Then x is equals to 1 and x is equals to 2. Now at x is equals to 1 and x is equals to 2, what happened to f of x? So if I consider f of x as y, so I have to decide the y coordinates on the graph. So at x is equals to 1 and x is equals to 2. Now substitute x is equals to 1 in f of x. So y is equals to f of 1. What is f of 1 here? So in the place of x substitute 2 into 1 cube, 9 into 1 square plus 12 into 1 minus 9 by 2. So here 2, 9 plus 2, 9 by 2. 12 minus 9, 3, 3 plus 2, 6 minus 2, 9 by 2. 2, 6 are 12, 12 minus 9, 3 by 2. So y is equals to 3 by 2. It is greater than 0. So y value is going to be 3 by 2. Similarly, y is equals to f of 2. So at x is equals to 2, what will happen to this f of a function? 2 into 2 cube, 9 into 2 square plus 12 into 2 minus 9 by 2. 2 cube 8, 8 to the 16. Next 2 square 4, 4 9s are 36, 12 2s are 24 minus 9 by 2. 16 minus 36 minus 20, minus 20 plus 24, 4, 9 by 2. So 2 4s are 8, 8 minus 9 minus 1 by 2. So if it is less than 0. So when you plot the graph, let us plot the graph here in a small space. When you plot the graph of this now at x is equals to 1, what happened to y value? It was reaching 3 by 2. 3 by 2 nothing but 1.5. Again when x is equals to 2, what happened to this y value? Half, minus half. So that means the graph will be like this. So it is touching the x-axis at 3 different places. So cubic polynomial, it is touching the x-axis in different places. And what is this 3 by 2 and minus 1 by 2 indicates? It indicates the turning point. So just now in the starting of the example, I said that to find out the turning points when the equation or a polynomial is given, take the derivative and equate it to 0. So at that particular 3 by 2 and minus 1 by 2, it takes the turning point. So that is going to be the equation. So let us check one more example. Check the multiplicity of root x is equals to 1 of p of x is equals to x power 4 minus 2x cube plus 2x minus 1. So this is the polynomial given. So what we have to find out? Multiplicity of root x is equals to 1. It has not been factorized, but we have to check how many times the x is equals to 1 is repeating. So what we have to do is same process. We have to take the derivative and then we have to go for the another derivative till we are getting the answer as 0. So what we have to do is first, so anyhow x is equals to 1 is the root of this polynomial, that means p of 1 equals to 0 will be satisfied. So p of 1, let us check it. So 1 power 4, 1, 1 cube 1, 2, 2, so it is going to be 0. So p of 1 equals to 0. So already it is a root of the given polynomial. Let us take the first derivative of this polynomial. So p dash x. So 4x cube, 3 2s are 6, x square and 2, and the constant is going to be 0. Now let us check p dash 1. Substitute x is equals to 1 in the place of 1 in p dash x. Now 4 minus 6 plus 2. 4 minus 6 minus 2 plus 2, 0. So it is also satisfied. So far, next, double derivative, p double dash x. Again differentiate this one. 3 4 is 12 x square, 2 6 is 12 x, and it is going to be 0. Again, substitute x is equals to 1. 12 minus 12. How much? 0. So it is also satisfied. Again, take the triple derivative. Again, differentiate the given polynomial. So 12 2 is 24x minus 12. Now put x is equals to 1 in the third derivative. So 24 into 1 minus 2. So 24 into 1, 24 minus 12, 12. Is it equals to 0? It is not equals to 0. So the x is equals to 1 of this polynomial is having multiplicity as 1, 2, 3. That is multiplicity as 3. So this is another example how to find out the multiplicity of the given 0 of a particular polynomial.